Hey, this is Ken Rosever, and I'm going to review another graphing problem with you guys. So here we go. Trying out a new Sharpie. The problem was y equals 3x over x plus 1 times x minus 2. So what's nice about this problem is the denominator is already in factored form. If it wasn't, if it was x squared minus x minus 2, we would probably want to factor it as soon as we began the problem. So we're going to graph this. We're going to begin by finding the vertical asymptotes. Asymptotes. All right. This one has 2, and they are found at the zeros of the denominator. Remember, they're the unshared zeros of the denominator. And there are no shared zeros here. So we have x equals -1. That's the 0 of this guy. And we have x equals 2, which is the 0 of that one. Next we go and do horizontal asymptotes. Horizontal asymptotes, we look at the degrees of the numerator versus the denominator. And the degree of the numerator is 1. The degree of the denominator is 2. Because if you FOILed this, this is what you would get, right? So the degree down here is a 2. The degree up there is a 1. Therefore, the degree of the denominator is larger. So this is case 1. Degree of denom is greater than degree of num. So therefore, the HA is at y equals 0. The horizontal asymptote is at y equals 0. So now we have 2 objectives completed. Next thing we're going to do is we're going to look for x and y intercepts. So I'll do x-intercepts. X-intercepts are found at the unshared zeros of the numerator. So we want zeros of num. What makes 3x equal 0? If x were 0. So the x-intercept is a point. It's a point on the x-axis. Technically, what we're doing here is we're setting y equal to 0. But we know, when does a fraction ever equal 0? Well, a fraction equals 0 if its numerator equals 0 and its denominator does not equal 0, right? If you have 0 divided by any number other than 0, you have 0. If you have 0 divided by 0, you have undefined. So if we want to find the x-intercepts, if we want to find where y equals 0, all we have to do is find the zeros of the numerator. So the only 0 of the numerator is 0, so the x-intercept is the origin. When x equals 0, y will equal 0. Well, that also must be our y-intercept, because a function can never have 2 y-intercepts. But just by way of proof, how do we find a y-intercept? We set x equal to 0. We find f of 0 is another way to write that. If I plug in 0 for x, I get 3 times 0 over 0 plus 1 times 0 minus 2. The bottom will be 1 times -2. The bottom will be -2, but 0 divided by any number is 0. So the y-intercept, which I found by setting x equal to 0, is 0, because it goes through the origin. So now I have all this information. It's not a ton of information, but it's enough that I can begin to graph. So there's my y-axis, my x-axis. Let me see. The vertical asymptote, I have one here at x equals -1. I have another one at x equals 2. I have a horizontal asymptote on the x-axis. That's hard to see, so I'll highlight these in a moment. And I have a point right there. That's actually a crossing point. That is a point at which the graph goes through its horizontal asymptote. Those happen sometimes. Let me highlight. I'll just highlight like this. So those are the asymptotes. We can never cross through a vertical asymptote, but sometimes we cross through a horizontal asymptote. The question is do we cross through like this or like this? To answer that, I need at least one more point. How do I find another point? I pick a value that is not one of my asymptotes or on the y-axis, because I already found that. So let's say we pick 1. We would do y equals 3 times 1. We're finding f of 1, basically. 1 plus 1 over 1 minus 2 gives me 3 over 2 times negative 1 gives me negative 3 over 2. So when x is 1, that's what I plugged in here, I get y is negative 3 over 2. So f of 1 is negative 3 over 2. Right here, I'm at a height of negative 1.5. Well, that gives me all the information I need. Because if you look back up to the top, and if you reviewed what I said you should review on page 268 and 269, you will know that because none of these factors are raised to an even power, at each of these asymptotes and at this 0, we will be crossing through the graph. And so if I'm coming from this point to this point, I got to go that way, right? And here I have to cross through. If this were squared, I would not. If this one right here were squared, because it is that factor, that x up there, that created this 0. If that were squared, I would go like this. But it's not squared. So I know I cross through here, and if I cross through, I can't pass through the vertical asymptote, so I must be headed up. Going the opposite way, I can't cross through this vertical asymptote, so I must be headed down. If I go out the bottom, this asymptote was caused by this factor. This factor is not to an even power, so I know there is a sign change here. Out the bottom, out on the negative side, it must return on the positive side. How close does it get to the axis? How quickly? I don't care, just so long as you know that it's up here. How do I know it doesn't cross through here and come back up towards it, like down and then up? Well, if it did that, we would have another x-intercept, and we only have one. All right, over here, it went out the top, so it comes back in the bottom. There's our graph. Pretty simple, all right? But you got to know a few things. Especially you need to know the behavior of graphs of rational functions near the vertical asymptotes and near the x-intercepts. So look at those rules. Again, those are on page 268 and 269. Check those out. All right, I'm going to do another one in a moment here. Bye.